All right, guys, welcome back again to the continuation of our data visualization class. In our second class, we'll talk about the visualizing a univariate variable, and specifically when we have a continuous variable. Remember, in a univariate, we can have either a continuous or a categorical. Okay, and we have different visualization techniques that we use on each cases. So we did talk about Instagram, we'll talk about density plot, we'll talk about the stem and plot leaf, and then we are supposed to talk about the box plot as well, but we couldn't cover all of that in the video. So I'll just quickly talk about box plot real quick. And the reason is that box plot works like it integrates two different things. You can use it to tell the distribution of your variable, and also you can use it to check for an outlier because it uses the five summary principle. You can see your first quartile, you can see your third quartile, you can see the median, you can see the minimum and the maximum. From just a visual, you can tell all of that, and if there's an outlier, you can easily tell. Okay, so now for the purpose of today's video, we want to look at the categorical part of the univariate case. Don't forget, like I said, we have the continuous and we have the categorical, and we already covered for continuous. So today we want to dive into the categorical phase of a continuous of a univariate variable. All right, so the first thing we're going to be looking at is, in the same way we have that, we're talking about the group, right? The first one we'll be looking at is the bar plot. So the bar plot, why do we even use it? We use it when we have a single categorical, whether it's nominal or ordinal. Now let's talk real quick about nominal and ordinal variable. We're going to get back into our notes, okay? So now let's talk about, so today we said we want to talk about categorical univariates, okay? And we said a categorical can be nominal or ordinal, right? So let's talk about ordinal. Ordinal means ordering, while nominal means no ordering, right? That's a shortcut to help you. When we say ordinal, it means that there are some specific categorical variable that they naturally have order. You understand? Take for instance, when we talk about class of degree, when we say first class, when we say second class upper, second class lower, those categorical variable they have ordered. When you say first position, second position, those are ordered. But when we say nominal, it doesn't have any order. One doesn't have a superior over the other. Take for instance gender. When we say gender, we can use gender as an example. We can use class of degree as example here. So gender, you can have a male or you can have a female. It doesn't have any under. Either one can come first, right? And when we have class of degree, we can have first class, we can have second, we can have third, and so on. So that's something we need to understand clearly. So, but the two of them still belong to the categorical variable. Okay. So now let's go back into our note. So we can use the bar plot for either case, and it's going to show the counts and it's going to show the share of each of the category under a variable. So it means that if we look at the nominal, let's say gender, we have either a male or we have the female. Let's say we want to know the count of female, maybe in a class or maybe let's say a course. Dr. Hair Academy 101 course, we want to know the total number of female that are taking this course. So we're going to have that. If you want to visualize it, we can see the count and then we can see the distribution of the female in the class, okay? So we have a major tip, which is you need to, it's just like the same thing we discussed in the principle, like labeling the category is very important because this time around, we have different categories in a particular variable, okay? So we have to properly label that and to ensure readability, of course. And things we should avoid, it means that we do not use bar plot for continuous data. If we want to use a continuous data, if we have a continuous data, we already talk about the type of plot that we use in that case, okay? So let's look at the code chunk here. This code chunk here is talking about how we can use backplot to explore the count and also show the proportion. So we're going to go into R real quick and demonstrate that. So if we come into our R settings, okay, let's look at this. So this is this is the code. All we need to do is highlight this, okay, and then run. So we can come in here, let's see the results. So we can see this is showing the count of each category that we have here. So now let's go to that code to properly understand what we just did, okay? So now we talk about the empty cars. That's the inbuilt R data that we are using. And we are looking at this particular variable called the cylinder. We can come to the help function to know what is cylinder, CYL, right? It's talking about the number of cylinders. And then I told you that anytime you use this function bar, we are talking about how we want to display our visual. And then now we call the bar plot function. In case you're getting confused, just use the help function to see the arguments and how you're supposed to put them. Okay, so we're calling this new assigned variable, which is taking the place of CYL. Okay, so we're calling that, we put in the title, we put in the label of the x-axis, and then we say we're doing counts. So we're doing two visuals in this case. This is the first visual, and then this is the second one, okay? So the second one as well, we are only showing the proportion, which we calculated to be the count divided by the sum of the cylinders that we have in the data, and then we want to see the proportion of those cylinders, okay? So that's what we just did. Now, one thing I usually do is you can come into your console and let's see the type of variable that cylinder is, right? So we can say table of empty cars, okay? Empty cars, what's the variable we are doing? CYL, okay? So when we do that, let me try to increase this so that you guys can see what I'm talking about. So we can see that we have three different categories of this variable. You know, we said the plots we're talking about for the categorical case. It means that we have how many categories? Three different categories under this cylinder. In the number of cylinders, we have three of them, and these are the counts of each one of them. So for 4, which is a number of cylinder, we have 11 of them. For 6, we have 7 of them, and for 8, we have 14 of them. So that's what this is saying. So that means when we come to our plot right here, let's reduce this. So when we come to our plot right here, we're going to see that plot. You can see. So it's showing that we have four category here. Let's come back to this table so that you guys can even see it better. So we said we have, so for 4 of this we have 11. It's showing the count. For 6 of this we have 7, and then for 8 of this we have 14. Okay, so this is what this has done. Now if we want to do the proportion, we need to calculate the proportion. That's what this did. Okay, so this calculated the proportion by taking the count divided by the sum of the tab. So we can come in, we can see the sum of, what is it? The tab, let's see the tab thing. Okay, that's 32. So it means that we are dividing each one of them by the proportion. Okay, and then we are seeing the proportion of that across different groups. So this is what we have just done. Now let's go back to our notes and continue from where we stopped. All right, so the next plot we're going to be talking about is the side-by-side box plot. Now, what this is saying is we may want to compare distributions of different groups. We want to see what is happening in different category. Now, let's go into why do we even use a grouped one? Let's say you have one continuous response and you have one categorical group factor, and you want to compare the distribution across those categories. Now let's go into our code chunky. We are looking at a variable called G, right? Which is coming from the weight. So the weight is distributed to the factor of J. The data itself is empty cars, and these are the titles. So we want to visualize and see different comparison of this. Now let's go into R because that's how we can understand this better. So if we come here, let's go to our code 6. So our code 6 is talking about comparing distribution across different groups. So when we run this, we are going to come to our plots. Now, this is saying that if you come to the GR, let's come to GR. Let's do a table of the GR so that we see that. So if I come here, I can say table of what? Of what is our data? Empty cars, right? Empty cars, and then I put in the to specify the GA. So if I do that, it says that I have three categories on this variable GA. We have three, we have four, we have five. When we come here, GA is the number of forward GAs in that particular variable, okay? So, and it's saying that we have three categories and each one of them has their corresponding counts. So we want to see. Now, if you notice that we have MPG, look at MPG. What is the structure of MPG? MPG is miles in US gallon. MPG is a numeric variable. Let's see the structure of it. The structure of our empty cars, the structure of empty cars, right? Now, if you come here, let's see MPG. MPG is what? Is a numeric variable. So this is continuous. So this time around, we want to see we want to compare across different groups. So we want to see the behavior of this with the miles per gallon. Does that make sense? So that's what we're trying to do, that instead of just visualizing individually, at times we want to see the differences across the groups. So that's why you can use like a grouped set in this case. So that is what this has done, okay? So, and you guys have access to all the code. So you can always reproduce the results and you can modify the code to submit your assignment. And we can also meet during our help session to if you're having any difficulty in that. Okay, so let's go back to our class notes so that we'll finish up on this section. And so, yeah, that's what we just talked about, that we use it to compare distributions across categories, and then we can see all of that. So, in the next video, we're going to be starting with the bivariate visualization because I want this very simple and easy for you guys to watch. See you in my next video. Bye-bye.